Multimaster at Qualcomm. I want to get you guys involved a little and ask maybe who here wants Multimaster on their servers? Okay, let me ask some questions. Why do you need it on your server? For failover, so high availability. Okay, so you're thinking like from a site standpoint too.
Yeah.
Right.
Yes.
Okay.
All that, but also latency. So we have developers in all the places. So we would have at least 2 data centers, one in the States, one in Europe, and latency for.
Okay, so you're looking also for sort of a multi-site, multi-master solution that would help decrease latency at each site.
Yeah.
Okay. Anybody else?
Yeah, mainly for me for scalability. And I have elasticity, ability to scale when the load is coming up and to scale down when the load is going down, and zero downtime as well. Rolling upgrade and making sure that I can keep the service up and running, even if I do some minor upgrades in Gerrit.
Can I ask the reverse question? Like, who runs a multi-master solution and would want to have a single master?
Single master? Who?
I would love if we had a single server that was powerful enough to serve all of our traffic at low latency, and we did not have to deal with slow database backends or replication lag between sites.
Does anybody say they need Multimaster? How are you surviving today without it if you need it?
Right now we create a second passive master server for DR purposes. So that will negate the need for a standby cold backup of the server.
Okay. So you have a passive
Yes.
standby. Do
Yes.
you fail over to it?
Yes, if our master went down, we'll have to.
We basically will need it soon. So at the moment we are, as a fallback solution, we are experimenting with HA plugin from Hugo. But I think that for us, like in perspective of half a year, it will be a must. So we don't like need it right now, but we work towards achieving this because we want to have a solution that scales basically, and that's our main concern here.
Maybe people can see there's definitely some different needs. I hear a lot of high availability, scalability, not necessarily the same needs. Of course, it would be great if Multimaster can address all of those, and that's probably some of the hopes. But I think it's important for everybody to understand their needs and to work, think about how they might approach addressing those first instead of just the big everything solution. We definitely have high availability as an issue somewhat. So we want better high availability. We have some scalability issues. We do have site issues at times, but generally we deal mostly with that through slaves. We have slaves all over the world, somewhere between 50 and 100 slaves. And we really have one primary data center in San Diego. If that goes down, nobody's getting any work done, even if Gerrit's up. Fail over to other sites is not particularly a useful thing right now. So our goals are more to have better availability and better scalability at the one site. So our scalability problems, we generally have pretty heavy load, and we probably have the order of 6,000 projects, but our load is mostly because we have a few large projects. They're not massive projects. They're large from the standpoint they have many changes in them. So there's a lot of users using those projects, and particularly a few main projects that are used. Our kernel projects are used the most. And so even though there's a lot of other little projects, most of those users are still pushing to that one project. We do have many users, so that we do have to scale there. And then we have a bunch of small projects. And so yes, some of those users are going across those, and we do build on Android, so we certainly have a large collection of projects that we have to sync from and also modify, but it's minor, the modifications to the rest of the projects in Android. We are single tenant on this server, and so we primarily want to deal with that. But of course, I would say we are a single tenant because some people want their own servers, and so they throw it out. So we don't have to deal with the multi-tenant issue really yet. But if we had a more scalable system, I suspect that suddenly multi-tenancy would become the next problem on the horizon, because, or one of the next problems, because now you say, well, if I have a great scalable system, why am I going to start up these little servers here and there? I'd rather put everybody on the main system so I manage one system. But then we have the problem that Gerrit today doesn't really handle multi-tenancy well. So maybe that's why, because maybe we don't have a multi-master system, so maybe nobody's ready to throw all their tenants onto one server anyways. So if we start getting more multi-master solutions, maybe multi-tenancy becomes more something that the community is more interested in. On this server, we have about maybe 6,000 projects. You know, some of those, the main projects there have 500,000 refs in them. And we have about 2.3 million changes total on the server. So I like to break down scaling, when people talk about scaling, into two sort of different ideas. I think of horizontal scaling and vertical scaling. On our area, we have a need to scale vertically more. And so maybe the difference here, I think of horizontal as you have lots and lots of projects and perhaps lots of tenants, so instances, and lots of users. Whereas our vertical, again, is we have a lot of users and a lot of changes and uploads, but they're not distributed across millions of projects or hundreds of thousands of projects. We're only in the thousands. But our projects are probably bigger from a change standpoint than most people have. 500,000 refs, 500,000 refs is a lot. So here's what we decided to do. And we decided the most important thing is to be able to do things incrementally. So these are the four sort of phases that we've attempted and how we've approached it. As you had mentioned, we had active, passive, standby. And one of the things we started really doing there is we said, let's do regular failovers. Because let's face it, if you have a standby machine you've never failed over to, it probably will not work if you ever try to. We have so much software around our Gerrit ecosystem. We have a lot of scripts and other things and cron jobs and things that run on our servers. And they use a lot of software. There's a lot of Python hooks and things like that. And that software gets updated. If your failover machine is not getting updated through the same process as your main master regularly and tested, there might be missing dependencies, there might be wrong package versions, etc. Maybe some hacks to the file system. Someone made a link to over here and it's not on the other server. Maybe file system positions are different, things like that. So to even dream about a multi-master, you have to have a way to make your server consistent. If you don't think your organization can do that, if you can't make two servers exactly the same and matching your production setup currently, you're probably not even going to be anywhere near ready to do multi-master, right? And that's if you're a large organization that has a lot of history, that's a bigger challenge. If you're starting from scratch, it's a lot easier. So if you're starting from scratch, think about that from the start. How can I, focus on repeatability and deploying the same software to multiple servers? And then let's focus on failing over. So I think sometime earlier this year, around February, March-ish, we started doing failovers, and now we try to do a failover weekly, leading up to now. So we've been doing that to try and just get used to it, get our team used to failing over, ensure our process of deployment works, etc. So then we moved to a hot standby, and I'm going to say the difference here was primarily in a passive mode. You had all the software, but it wasn't necessarily running on the other server. Hot standby, we literally just bring up the other master and it's running, just no one's pointed to it. But it's pointing at the same data, and it can go. So during that gives, the hot standby and even the passive standby, they both give you the opportunity to start testing all of the software you have around your master. If you have hooks, if you have cron jobs, try to run them on the failover server, even though it's not the active master. See if they can. Do you have the coordination needed to do that? Do you have locks in place that if you do, for example, repository repacking, if you're doing that, can you do it on both servers at the same time, or are they going to interfere with each other? Things like that. The assumption here is, and I'll get to it, is that you have a shared repositories on a back end, such as NFS, some shared file system. And so activities like repacking need that coordination. And that's a lot of stuff you can work out long before you get to multi-master. So the third step, which is where we're at, and we just chose this as a simple, low-tech, simple, really easy to back out solution, round-robin DNS. Sucks from a load balancing standpoint and various other things, failover recovery, but it gets us to have traffic going to 2 servers. And we've been running that for quite some time now, about 15 hours. And the next step, of course, would be to add our load balancers in, and we already have a load balancer set up that we use for slaves, and so that's fairly well. We didn't move straight to that just because it's harder to back out. You have to change IPs, get reverse NAT set in place, and various things like that. That just makes it a little harder, but we plan to transition to that. All right, so you probably saw some of this in Patrick's presentation. What sort of data, needs to be shared in a multi-master environment. So to be clear again, my site is a single site multi-master. Everything you do on a single site, you probably need to do on a multi-site also. In your single site, you're going to need to share your Git repositories. You don't have to share your H2 caches like I have it under shared, but you need it on each of them. And your SQL database needs to be shared. That goes away when the database goes away. So we additionally have some other stuff we need to share, and we need to share web sessions. So what does that mean? That means when you log into your web browser, if you first hit one machine, and it says the server keeps track of that, it knows that you're logged in. You have a cookie on your side, but that server knows, oh, he's logged in from that cookie because it shares persistent data. Well, if the next hit goes to the alternate server, you don't want the user to be logged out, so you need to share that data. In 2014, we developed the Web Sessions flat file plugin, and that helps take care of sharing web sessions. I know a lot of people have used that already for their HA solutions. And it's fairly simple, it just stores data in the file system, and if your repos are on NFS, just put it near the repos, share that also. The other thing you need to share, for us, we need to share events data. We made events persistent on the server side, and so we share them in a file system also, and that allows us to then share them across masters. If you connect to one of our masters with SSH, you'll get events from both of the masters. With sharing it through the file system, and that's like sort of the poor man's sharing. It's really simple, no moving parts, it's just there. One of the things we realize is if we move to a multi-master, your events are going to be disrupted potentially more. Even though you think you have higher availability, with SSH, the client can only connect to one server. So it doesn't matter if you have a cluster of 10 servers, they're still only connected to one. And generally speaking, most of us want to be able to do rolling upgrades, et cetera, and be able to bring a server down. That's why one of the reasons we want to go to multi-master. If that's the case, if you start doing that more, you're actually disrupting your SSH clients that are permanently connected, such as the events, even more. So we wrote a plugin called the Events plugin. I merged it upstream during the hackathon this weekend, so it's available upstream if you want to take a look at it. And helps you store stuff. You get the added benefit. You can add some flags to get IDs on your events, and then you can replay IDs. So since it stores them in the file system, when you reconnect, you can tell it where the last ID you connected with, and it'll start and send you all the events after that. It's done through the same UI interface as the old events. So that's just drop it in and it works. It respects permissions and things like that. So it evaluates just like the current plugin the core feature does. It checks your permissions and doesn't send you events you don't have the permissions to see. So we also have a batch plugin. I spoke about that last year at the conference. It allows you to prepare, merge a bunch of changes together on the server side and then test it before merging those changes. So that has some persistent data. So we also share that, but that's just a flat file. So it's pointed to NFS, done. Processes exist on your server. Obviously we have the Gerrit JVM. But we, as I mentioned earlier, we also have a lot of hooks, a lot of legacy hooks that just run. Some of these run a long time. So you need to be able to get those to run on both servers. Additionally, we have a few cron jobs. We have Git repacking that runs. And we have a thing that similar to what Hugo has that does user auditing. It checks LDAP, makes them inactive depending on the status there, and checks various other things about their emails to make sure they're sane. And I suspect anybody else running a server has various maintenance cron jobs they have to do too. So we focused on the background stuff first because you got to get that stuff. And you can do that piecemeal. So we did that, and we decided to try and coordinate those. So what we do, we went for the low-tech solution first, doing as much as possible via the file system. So years ago, I created a lock that basically just uses directories to make a lock. It's similar to the average, echo PID to a file. It's a lot more robust, though, and it has the ability to recover deadlocks as long as it can contact the other server using SSH. And so it does all that automatically. So we use that as the primary thing to coordinate things. On top of that, I built a scripting queue executor, and we use that for our hooks. Many years ago, long before Multimaster was on the front, we had issues with hooks just running too long. And if you know anything about the way the Gerrit hooks work, they get in the Java process, you have a queue there, but it only runs one at a time. If your hook takes 3 minutes, you may have a backlog in your process. If your server goes down, you lose that backlog. So the first thing we decided to do years ago was write only thing the Java process does is just write the data of what the hook was to a file, and then we have scripts that run it in the background. So all those, basically the queue in Gerrit is always at 0. It's almost instant. It takes like a second or so to write it to the file, and it's done. So we made that multi-master friendly because those queues use the locks that are above, and that's all we had to do is make it multi-master friendly, and it just worked. So now you can write hooks to a file from one server, and the other can actually be the one running it. So it'll distribute the load nicely that way. The other thing we had to think about is there were various other things that are based on node or cluster startup. So we just put a hook into the startup script, and I created a little cluster framework that keeps track of which servers are running, and it can check to see if they're running by SSHing into the other server, and checks the PID and make sure it's still running. That allows us to identify, for example, if with 2 servers, if there's none and one goes up, okay, now your node starts, but also your cluster starting. If the other one comes up, now you're not really starting the cluster, you're just starting the node. And then when you're going down, if one goes down, you haven't stopped the cluster, you've only stopped the node. And then if the second goes down, you now stop the cluster. And I basically created a little hooks framework that you can plug into those events. And so then you can do things based on that. For example, on startup of any node, we always start the hooks just to make sure they're running. But we only stop the hooks, we disable them when the last node in the cluster goes down. Because now, if one goes down, the hooks can keep running because they can still contact the other server. Because they just go to the domain name, not to the local server. So that's what we use the framework for now. We plan to use it for replication too. Currently, if you're familiar with how the replication plugin, what does it do on startup? It pushes everything, or it tries to check basically, doesn't replicate all to all your slaves on every project to see if it's up to date. The theory being, I guess, that data could have been modified behind Gerrit's back when the server was down. And also maybe perhaps when the server was shut down, it was in the middle of doing something and it never finished. In a cluster situation, well, if you always have, anytime something goes down, a server goes down, it could have been in the middle of replicating and the other node won't know it. So when any node goes down, you're going to want to replicate. But there's really not a need to do replication on startup when any node starts, only when the cluster starts. So as long as a node is up, when the second node comes up, you really don't want to do replicate all. You could, but it's just extra load. Some other people have done things like this. You can do a lot of this coordination with something better than just the file system. You can make a one-to-one connection. I think that's what the HA plugins do. They have to configure the IP of the one master into the other, and then it connects directly to it. And that works well for two, not a super scalable system. It's an n-squared problem. And so eventually you probably want to move to a pub sub system for things like that. Oh, something I didn't mention in here, another thing we have to do cluster coordination wise is you have to think about caches. The HA plugin evicts caches. We haven't done that yet. We consider that an optimization. The primary thing we do is just reduce the time on a lot of the caches. We basically reduce them to the values that we had on our slaves, because most of you probably have lower cache times on your slaves. You have to make sure you're checking your project ACLs and things like that in your group memberships a little more often than the master usually does, because the master knows when they change, so it doesn't have to evict some things. But the slaves do, because they don't know when it changes. So we made our masters a little dumber, like slaves. They know when they've evicted something, but they don't know when the other guy evicted. So as long as you're okay with a certain delay, set your cache to 5 minutes or something like that for your projects. And that just means if you make an ACL change, it might take 5 minutes to get to the other master. Has anybody ever just tried to run 2 Gerrit instances on their laptop? So on startup, you'll probably run into the problems you said. First of all, if you're pointing it to all the same data, well, your H2 cache is it won't start because there's locks. So first thing you got to do is make sure they're pointed to different H2s things, and that probably would. But if you actually ran init on 2 different directories, you're not going to share any data, so then you have to actually manually tell it, or you have to modify the config files to share. So what can you point? You can point your database at the exact same database. If you're running on a laptop and it's an H2 database, well, you can't do that because H2 can't be shared. But if you had a Postgres database or a MySQL database, it's no issue. Just point it to the same one and you can share it. I'm running 2.14 here, and so I didn't share the indexes, so they're going to be out of date and stuff like that. The web sessions aren't going to be shared, so you have to manually make them shared, and you have to get them out of the database. Currently, they're in the database. So if you use the web sessions flat file plugin, it'll put them in a file system, and then you can share them. Lastly, your events basically won't be shared. But most of the rest will just work. I'm going to try it. This is stream events. So on the left screen, you can see that I'm connecting to port 2418, 29418 as usual. And on the right over here, I'm going to connect to 29419. So I'm running the stream events here on both of them. So now let me go to the web UI. So here I'm running on port 8080, which maps to the same process that has the one on the left. And I'm going to create a project. And I hit create. Note the event received over here on 29418, but nothing over here on 29419. Makes sense? It wasn't on that process. Let's try to go to port 8081. I have to log back in. Non-shared web sessions. So I'm showing you this is what it does out of the box, effectively. Create a new project. So it came on the right screen. 2 independent servers, mostly, and except they are pointing to the same Git data today. So basically, I'm trying to make a multi-master, but it's not really working very well. So let's step in and copy our new plugins. So restart our servers. So one thing we did with these new events plugins was we created the events plugin. And so instead of getting to the Gerrit stream events to get to events, now I can go to events stream. Events being the plugin name and the action being stream here, the command. What we actually did in core is we remapped the Gerrit stream events to a command called stream events-core. And that allows you to still get to it if you want on either one of the masters if you went to the direct IP, and this helps for debugging. And then we made an alias from the Gerrit stream events to the event stream so that all users inherently get the new plugin. So to them, it's invisible. There we go. Connected over here. So I'm on 8081 if you notice in the browser there. So that's should be on the right one. Create a Luca. There we go. Events on both ports. You notice it did show up on the right first, then it got to the left. So what I'm doing there is the events are in the file system, and the other server either needs to poll, which I have a 1-second poll here right now to see if there's any new events, but it also, anytime it outputs its own events, if something happens on its server, it'll catch up on any events that happened on the other server in between because they're sequential. And so it'll just spit them out then. So the polling is really a backup. They should get output even without polling. So even if you set that to a larger number, you should be fine. And if we eventually add a pub/sub mechanism, I would suggest to still keep the polling. I always think all event systems should always be backed by a polling system because events inherently will get lost. So you need a polling mechanism if you want true reliability. Polling is not great, but it is reliable. Events are an optimization for speed, effectively. And so here, that's what we got. So let's see. Let's go to the other server. So I went to 81. Now let's go back to 8080. Yeah, I didn't have to log in. Kept my session. Create a project. Let's do a Hugo project. Since I'm in 8080, it should come on the left this time. There we go. Came pretty quick. So you have now both shared web sessions and shared events. That's in 2.14. To make a 2.14 a true multi-master, you would need to share your indexes and get those updated. In 2.7, we don't have an index. We don't need to share it. So that's it. The events plugin, we've been using that in a non-multi-master way, the same plugin since about early this year, and it's been fairly reliable. I can show you a few other features I mentioned about in them. There we go. There's some new options here. IDs and resume after. So if I give it a -- IDs and a -- resume after 0, I'm just going to say, boom. Those are all the events since I started the server. Since I started the instance, not so I initialize it. So even the ones the server's been started and stopped a bunch of times, you've seen that, but it still had all those events. So there. That replays them, and if you see, I've added an ID here to each event. And you see there's sort of two parts to this. You have a left part, which is a UID, and a right part, which is a number. The idea being, this is your file store. This is your event store. It's a unique ID to say if someone went on disk and deleted it, it would create a new one. And the idea being, now you can tell, well, you don't have any of the new. If you were at event 1 million and someone went and deleted that, and you said resume after event 1 million, well, the new event store would, if someone recreated it, would start at 0. You'd get nothing. So by having a different ID, because it inherently creates a new one every time, you would then, if you said start at 1 million and it realizes that the UUID has changed, it realizes, well, you need everything, because basically you haven't gotten anything since the new one, so it'll just send you everything. So that gives you a little extra safety there. So that event plugin works with 2.14. It's been, I think there's a change up for review to make it work with 2.15 too. So if you use Hugo's HA plugin for the index, you basically could probably do it. So why do you guys not do it? I think you guys are concerned over NFS and Git ref updates generally.
Actually, we use it in failover mode for the only reason is if you just have a little bit of load, you're okay. Like the writes to the NFS will be okay, so consistency will be maintained, like no repo corruption. But if you push it a little bit, like storing files, sharing files, NFS from different machine doesn't work. You cannot have two machine writing to the same NFS at the same time in the same repository. You're gonna lose history, and it did happen, we know. So that's why we don't do it.
So we've been doing writes on our system for several years now using an NFS, and we haven't seen any issues because we do repacking all over. So perhaps we have different NFS settings or something, or just different implementations.
Yeah, for us it didn't happen that often, but like once, twice a year, not that much, but still it's happening. In theory it's possible, so that's why we're just not doing it, but we're planning to try to find a way to fix this and just like go with like 2 active nodes.
Right.
But actually the HA plugin is actually taking care already of the eviction of the cache too. You don't even need to lower your cache settings on the master cluster. It just works. It evicts the cache on the other master, takes care of the events in a slightly different way. And the secondary index, they each have a copy, so it works. So for us, actually, we keep switching between nodes like in the middle of the day and nobody can notice anything, no difference at all, no delay, no nothing. Just we're a little bit hesitant to write actually from both nodes, but that's the plan.
So you're basically in a multi-master setup almost. It's just
Yeah,
you're
we're
not
at
sending
step
traffic to
2.
both.
Yeah, we're at
So-
step 2 actually of one of your
Right,
slides.
or 3 really. But yeah, I've heard your reports so I'm keeping an eye on things in NFS. I'm confident we can fix any issues that we think that show up if there are any. I think understanding the way Git works on NFS and stuff, there are some tricks that we can pull. I know in the past we've fixed a bunch of stuff in JGit to handle NFS. What happens when you delete a file in NFS and someone else tries to access it from a different node? NFS stale file handle, right? So that's the main problem that you run into. And really, we countered and fixed some of the things in JGit. There's probably still a few issues left here and there, maybe. The main fix for that is just before you delete a file or overwrite it with a different file, just make a copy, a link to it, a hard link, and then it stays around, and delete that hard link a little later, and you're fine. That way, any processes that have the file open will still be able to read from it because the inode's still there even after you've moved it or delete it if it's been linked somewhere else. And so generally speaking, it's only a transitory moment that it would be a problem. So even if you keep it there for a few seconds, you're likely to survive. And it basically ends up making NFS act like a local file system when you do that. Because if you delete a file in a local file system, the inode is still there until it's unreferenced if you have it open. And so that's really the only issue that we've mainly run into, and most of those have been fixed in JGit. I think you've had no issues, right? That has helped you, right?
So I may have missed you covering this earlier, but so the shared file system approach seems to assume that you're not doing multi-site, right? Because if you had multi-site, then there'd be some extra latency, which might bring back the same problem that you were trying to solve with multi-site, multi-master. Is that fair? Or?
That's correct. We're like I said earlier, we're really not so interested in multi-site. For one, there are downsides to it. It's a lot more complicated, and it makes it slower. Ultimately, your writes are a lot slower. Your reads will be faster, but as you can tell when you push to Gerrit Review, it's not always the best push experience. So, and that's because you have to go to a quorum of majority of people around the world, sites around the world. So single site is step 1. Multi-site requires a very different approach because now you have to basically take the refs, the Git objects need to get replicated, and you have to do something to the refs to make them shared. And without a system like Google's database that is replicated around the world, it's pretty hard to do. So it's not impossible, and we've experimented with it. I think years ago, Dave uploaded an open source Zookeeper implementation to do the refs. But that only does the refs, so then someone would have to add the object replication, which you could use the standard replication to do if you were, but you'd have to sort of come up with a ref scheme that, that's a little bit magical behind the scenes to transfer things.
So touching on that, last year we started and we presented at the hackathon a new implementation for the missing part. It is using Cassandra. So the implementation overall will use the Zookeeper implementation that Dave did for the refs, and for the Git object was using Cassandra. And we are making progress on that, and that will be possibly the solution for the multi-site. But actually wanted to ask you one question, because we found out and we fixed in the recent version of JGit a problem about the JGit cache. So it means that was appearing when you're using NFS, but and nothing to do with NFS, but was related to the fact that when JGit is not able to open a file for whatever reason, latency, whatever, so the JGit cache was thinking that the pack file doesn't exist anymore, and then was not able to find the objects anymore in memory, and you were just panicking by saying, oh, my Git repo is completely screwed up, and it would say, but what the other nodes are seeing. So this is possible screwed up just for one node and not for the others, and you didn't know what's going on. And then magically when you restart Gerrit, oh, but it's not screwed up anymore. So there was a bug in JGit that we fixed, but I believe that has not been fixed in the old versions of JGit. So did you find this problem on 2.7, or how did you manage to keep up with the latest version of JGit on 2.7?
So we have an old version of JGit. It has some of our own patches in it. I think we fixed a bug like that years ago. So, but we did try. We've ported a few things, but we have some performance improvements and things that are ours that aren't upstream yet. That
So we have a fork of Gerrit and a fork of JGit.
yeah, and those performance problems, you know, we ran into those 5-6 years ago, and we had to fix those long before upstream could get to it. So, but yeah, it's not that big of a fork of JGit though. It's only a few things, and we've pushed most of it upstream. Some of it just hasn't been merged.
Okay.
Yeah. It's hard sometimes getting JGit stuff merged. It's not enough maintainers to even look at the stuff, seems like. We added some of those SSH locks that I talked about in the file system so that because we rerun GC off of all of our slaves too. So in San Diego, we have a site with 2 masters, and we have 11 or 12 slaves there, and they all read from the same NFS. So the NFS part has been there for years. It's been fairly well tested. And we distribute the repacking off all of those machines, the masters and the slaves. We distribute across all of them. And they basically, we keep a list in a file system of the repos, and each one checks out basically and says, I'm going to do this. And then the next one skips that one and goes on out. So it gets fairly well distributed, and that's why we can get it done in an hour, or else it would take several hours to go through the whole thing. So that prevents them from at least stomping on each other from doing the same repository. From a repacking standpoint. As far as backups are concerned, we just do an rsync and take database dumps. So we don't get a consistent image necessarily. So Gerrit can generally handle a somewhat, you know, as long as I think you have to probably take your database backup first. If you run an older database, then your repos, you're probably safe.